Now we'll take a look at regression analysis, but before we do that, let us look at how regression is different from correlation. Now in correlation, both regression and correlation talk about, or they deal with the relationship between two variables, say x and y. But the way they analyze the relationship is different. In correlation, we're able to find out the degree and direction of relationship, whether it's how close the relation coefficient is closer to -1 or +1, or is it equal to 0. In regression, we talk about the nature of a relationship, and here we use these concepts, the concepts of dependent variable and independent variable. So because of this nature of relationship, when the value of one variable depends upon the value of another variable, we are able to establish a cause-effect relationship. But in correlation, we have no such study of the cause-effect relationship, because correlation does not imply causation or no causal relationship. And correlation simply gives us the correlation coefficient. In regression, we get the end result is an equation. And because of that equation, we are able to predict the values of one variable based on the other. So, like correlation, we have different methods of analyzing analyzing regressions. Okay, so we'll talk about two methods: regression coefficients and least squares method, because in case of correlation, we only have to find a correlation coefficient, R. But in regression analysis, we are interested in regression equations. So there are two ways where we can find regression equations. The first method is one which uses regression coefficients, and the other is based on the concept of least squares method. So we'll take up the first method, or the first way of determining or finding out regression equations. So, and this is called the regression coefficients. Now from the definition here, we see that a regression coefficient shows us how much the dependent variable will change when there is a unit change in the independent variable. In other words, what will happen to the dependent variable when the independent variable changes by 1. So let us take two variables, x and y. So if the regression coefficient of, let's say, the regression coefficient of y on x. So here what we are saying is y is the dependent variable and x is the independent variable. So if y depends on x, the regression coefficient of y on x is represented as follows. So byx, or regression coefficient of y on x, is equal to the covariance of y of xy divided by the variance of x. And if we expand this is the formula. Similarly, let's take another case where x is now the dependent variable and y is the independent variable. The regression coefficient of x on y is given as follows. This is represented as bxy. So the regression coefficient of x on y is the covariance of xy, of x and y. Here we have the variance divided by the variance of y, and if we expand that, this is what we get. So the regression coefficient is nothing but the covariance divided by the variance of the independent variable. So now we've looked at the concept of a regression coefficient and the formulas. Now we can apply this concept to find regression equations, because that is our ultimate aim, to form regression coefficients. So the meaning of an equation is to show a relationship, and in regression equation we are interested in a causal relationship, and for that we have dependent and independent variables. So the purpose of a relationship is to show that one depends on the other, or a dependent variable depends on the independent variable. One is the cause, one is the effect. So what we need to have, okay, is for an equation is to have the dependent variable on the left hand side and the independent variable on the right hand side. So suppose here y is the dependent variable, y is the dependent variable and x is the independent variable. So the regression equation of y on x is as follows, and we have already seen previously byx is nothing but the regression coefficient of y on x. So it is here where regression coefficients are important, or they become a part of forming regression equations. Next, suppose x is the dependent variable and y is the independent variable. So here when y depends on x, we see that y appears on the left hand side, x appears on the right hand side. So that is how we know y is the dependent variable and x is the independent variable. In this case here, x appears on the left hand side, y appears on the right hand side. So this tells us that x is the dependent variable and y is the independent variable. So the regression equation of x on y is as follows, and here bxy is the regression coefficient of x and y, of x on y, and the regression coefficient is nothing but the covariance of the variables divided by the variance of the independent variable.